Hi, this is Santi Untañon from Brain Games, and today I wanted to talk to you again about my latest project called MDL. So I had already uploaded a couple of videos, I don't know, maybe a few months ago about MDL, but I just released a new version, version 1.4, and I just wanted to take that chance to tell you again about what can MDL do and also about the latest features that are included in version 1.4, and also a little bit just explain how to use it, right? In case anyone wants to use MDL but you don't know how to use it. All right. So in this video, what I wanna say is first a reminder of what is MDL, and then I will tell you about two things. First, how can you optimize code with MDL? The second is what else can MDL do? MDL can do a lot of other things. And finally, I just want to talk about what's next. What are my future plans for MDL, and where do I want to take it from here? All right, so let's get started. So first of all, what is MDL? So as I was saying at the beginning, MDL is an optimizer for assembler code for the z80 processor. So the input of MDL is basically a program in assembler, so a text file or several text files. And what MDL does is it finds ways to make this assembler program smaller, basically use less bytes, or a bit faster, right? And it can do this in several ways. You can, for example, ask MDL to give you suggestions if you don't want MDL to actually modify the code directly, and then you can implement those suggestions yourself. Or you can ask MDL to actually generate the assembler code already optimized, right? So you take assembler as input, and it would generate another text file or text files with the same input assembler code, but already optimized. And MDL is open source. You can find it in GitHub. And why did I build MDL? Well, I spend a lot of time optimizing code when I work on my little MSX or mainly MSX, but some Amstrad, and I would like to also do some Spectrum projects. So I spend a lot of time in those projects basically optimizing code, right? I really like imposing myself constraints. So let's see if I can do this type of game, but using at most like a 32 kilobyte ROM, or at most a 48 kilobyte ROM, right? So I spend a lot of my time optimizing. I find that a lot of fun. I really enjoy it. So I thought, okay, would it be possible to build a tool that can help me do these optimizations that I usually do by hand, but automatically, right? So I can use my optimization code, my optimization time more at a higher level, all right? And I can let MDL do the low-level optimizations. And also for fun. I mean, building MDL has been a lot of fun, and I'm learning lots of things while working on it. So yeah, that's another motivation for working on MDL. All right, so after that, the first thing I want to explain is how do you optimize code with MDL? So in the latest version, in version 1.4, there is two optimizers. The first is a pattern-based optimizer, which was already there in the earlier versions. This is the way MDL started. But in version 1.4, there is a new optimizer, which I call the code reorganizer, that can do further things than the previous optimizer couldn't do, right? Okay. So let me just show you how to use these two optimizers. A folder where I have prepared mdl.jar, which is what you would download from the GitHub website. Of course, you can also download MDL source code if you are interested, but all you need to run MDL is the jar file. I also have Glass, which is the assembler I usually use for my games, because I want to show you something later. But for now, we're just going to use MDL. Okay, so imagine I'm writing a program. Let's say I have some code region. I'm going to save it as test.asm, so I can have syntax highlighting. I also have some memory region, and I have a variable that is 1 byte, and I just want to write a 0 there, right? So I can do, for example, ld a comma 0, ldhl variable. I don't know how to type. And I can then just say ldhl comma a, right? And then I just want my program to stay in an infinite loop after it has written the 0 to my variable, right? Okay, so this is my program. It doesn't do much, but this is what I have. And I want to see now if MDL can find any way to make my program faster or smaller. So I just say java-jar MDL. I want it to read my test.asm. And now I have to tell MDL what to do. So I want it to run the pattern-based optimizer. So that is triggered with PO. Oops. And of course, I cannot type. So that would be Java, right? So it has run, and it has found one optimization. So it says, oh, you can replace this LDA A,0 by an XOR of A, and that saves 1 byte and 3 T states. And I say, okay, that's very good. So now you could choose now, go to your program and optimize it yourself. Or you could say, oh, come on, MDL, I'm lazy here. How about you do it for me, right? So you can just say -asm, and I want to save it in, let's say, test.mdl.asm, right? So I do that. It does the same thing, but this time it actually generated this test.mdl, which if you look at it, it's basically the same program, except now it has replaced this LDA A,0 by this XOR, right? You might see that MDL has modified your program a little bit. It has added spaces here just for having some better syntax. And it has also replaced this DS virtual by this org. This is because MDL doesn't know which assembler you're going to use later on for compiling your code. And not all assemblers support all directives, right? So this DS virtual, this is glass syntax, right? So maybe some other assemblers that you use do not understand this, right? In some assemblers you have to write define space or defs or different syntax, right? I cannot remember now. So what MDL does is just writes it in a way that would be understandable by all of the assemblers, right? So this is a bit nasty. It looks pretty ugly, but it's interpreted correctly by all other assemblers and actually means the same, right? Okay, so that's good. So MDL can find this. Let's see if it can find some optimization a bit more complicated, right? So let's say that you are someone like me and you don't write very good code. So for example, here I move that instruction down and I say jump to a label 1, then I put it here. And now I want to jump back to my loop, right? This is exactly the same program, except that now I do a little bit of work here, then I jump somewhere, then I do this, and then I jump back, right? So these two jumps are useless, right? I shouldn't have that. So let's see if MDL can catch that. So if I call it exactly in the same way, it is not going to catch it, right? So if I do it, it's still going to find only that one optimization, right, of replacing this XOR. But the new optimizer, the reorganizer, the code reorganizer can actually catch that. So if I want to trigger the reorganizer, I say -ro, right? And notice that I put it before because MDL runs the different steps in the order in which you specify them in the command line. So if I put this RO and PO after this ASM, it will first save to assembler and then optimize, right? So it will write this before optimization, right? Maybe that's what you want, but that's not what we want now, right? So we do that, and notice that now it has found more things, right? So it says, for example, you can move lines 9 to 12, right? So these lines, you can move them right after line number 5 in this file. So right after here, right? Which is right. We could move this just here, and we save this jump. And then now that we've moved this here, it says now you could also move lines 6 to 8, which are these ones. You could move it right after here, right? And we save this jump, right? So it has figured out that we don't need either of the two jumps. And then of course it has also found the previous optimization of replacing that LDA, 0, right? So Every time we remove a jump, we save 3 bytes and 11 t-states. So 3 bytes plus the 1 byte before, that's 7 bytes, right? And we can see that the result is that MDL has actually found this. So it has moved all of this up here, right? So this block that was down here, it has moved it here, and then it has been able to remove this jump, and then it has also been able to remove this other jump, right? Because this just jumps here. And every time MDL removes a line, it adds this annotation, right? So you know that MDL removed something, and every time MDL adds a line, because sometimes MDL does add a line, it will say plus MDL, right? Okay, so this is fine. This is good. But notice that this is not fully optimized depending on what is your goal, right? So sometimes you want to optimize for speed, sometimes you want to optimize for size. And let's say that we wanted to optimize for size, right? So there is here an absolute jump. This is a 3-byte instruction, right? An absolute jump to this label. But this could be replaced by a relative jump if space is what matters to us, right? So MDL by default doesn't know if you want to optimize for size or for speed, right? So it will not assume anything and just do only those optimizations that help both in size and speed. But you can actually tell it, right? So let's tell the pattern-based optimizer that we want to optimize by size, right? And now we run this again. And now instead of 7 bytes as before, now it has been able to optimize 8 bytes. Because if you look at the result, now it has been able to replace that jump, absolute jump by a relative jump, and this is just a 2-byte instruction, right? So it has saved another byte. Right? So this is good. So you can do the same thing with speed, and actually this works because the pattern-based optimizer in MDL, the only thing it does is it has a bank of patterns, and it tries to match those patterns with your source code, and every time one of those patterns matches, then it knows it can apply one optimization, right? So by default, it uses one set of patterns that only optimize both for size and speed, but never reduces size at the expense of speed, for example. But if you are interested on speed or in size, it uses a different set of patterns that target either size or speed. But you could define your own set of patterns, and here, instead of size or speed, you could just write the path to your pattern file, and then MDL would just use your own custom-made patterns, right? So it can actually do that as well. Now, let's do one more thing. So this assembler file that I wrote is fairly standard assembler syntax, right? But some assemblers use very fancy syntax. For example, if you use sjasm plus, you can write this. You can separate instructions by columns, right? I personally don't like it, but if you like the syntax, you might want to use sjasm plus, right? And if I try to run this file through MDL right now, it will give me an error, right? You see, it cannot parse this line. Because by default, MDL doesn't know which assembler dialect you're using. So it just uses a default dialect that can only parse very basic assembler constructions. But MDL supports many different assembler dialects. So in this case, that column that I added there, that is sjasm plus a syntax. So I can just say, I'm using the dialect sjasm plus, right? Or sjasm plus. Not plus. Right? I don't know how do you pronounce this. sjasm plus. And now it can actually parse it fine, and it optimizes again the same 8 bytes as before. And in the output, we see that it has properly interpreted this as 2 instructions, and it has separated them. So MDL in the output, it will always generate just basic assembler, right? So that you can assemble it with with any other assembler compiler. Now, this is for sjasm plus, but if I just do java-jar MDL, this will tell me all of the command line arguments. MDL has lots of command line arguments. I'm not going to explain them all today, of course, but this dialect flag is the one that specifies which dialect. So by default, it uses the MDL dialect, which is just some basic assembler. I just use the SGASM Plus, which is here, but it supports many others like ASMSX, ASMSX-Zilog. This is basically ASMSX, but using parentheses instead of square brackets for interactions. It supports Glass, SGASM, TNI-ASM, WinApe, which is WinApe is an abstract CPC emulator, but it has its own assembler with its own particular syntax, so it also supports that. It supports PASMO, and also SDCC is a C compiler that internally it uses some assembler, which I cannot remember off the top of my head now. How is it called? But it has a very particular syntax, very weird. So if you want to use that syntax to optimize assembler generated by SDCC, you can use that dialect as well, right? Okay, so let's do something a little bit more complicated now. To open the Xpelunker folder, Xpelunker is a game for the MSX that I built a couple of years ago. And I've also opened the folder in Sublime Text, which is the text editor I like. And what I'm going to show you is how to use MDL directly on the text editor, because not all of us like using the command line, right? I particularly like the command line, but it's sometimes hard to read some of the output, right? So how about MDL can tell us the optimizations directly on the editor, right? So I'm going to show you how to do it in Sublime. But if you go to the GitHub page, you will see instructions also for Visual Studio Code and for Vim. And basically I have those three because, so the Nestro who was the one that created he was the very first one to integrate MDL with an editor. He integrated it with Visual Studio Code and explained me how to do it. So then I integrated it into Sublime, and then President Fubu, another user from GitHub, then saw it and integrated into Vim. Right? So those are the three instructions I have. But probably it can be integrated into many other text editors. So yeah, you just have to see those instructions, and maybe you can replicate that for your favorite text editor, right? So how does it work? So in Sublime, I just defined a command to call MDL. So for example, I open here the main file of Xpelunker, and I'm going to hit Command B, which is the key combination I have associated with MDL. So now it has just run MDL, right? So you would say, oh, but this is the same as in the command line. Yeah, sure, but now I can just click on these results, and you see this annotation. Now I can replace, for example, here, this string of 4 inks by this other sequence of instructions, right? Which is basically put L in A, add 4, and back. Doesn't save any space, but it's a bit faster, right? Or this one, right? So for example, here it says, this is a comparison with 0 because this constant is actually 0. Therefore, we can optimize this and replace it by OR A, right? That saves 1 byte and 3 T states, right? So we have here all the optimizations, and if you scroll up and down the file, you will see all the optimizations scattered through the file. So you can directly just do them and then call MDL again. So now this is the way I use it. So when I'm working on a project, I just regularly just call MDL, and it constantly tells me optimizations, which is very handy. So in this case, it found optimizations to save 53 bytes. This is not much, but this is the default optimization. If we want to optimize for size, actually the current version of MDL can save almost 700 bytes out of the Xpelunker binary, which would have been amazing when I was working on Xpelunker, because Xpelunker is a 32 kilobyte ROM, and I had to leave things out of the game because I couldn't fit them into the ROM. There was this item that was a glove that you could use it to get stuck to walls, and I had to remove it from the game because I couldn't fit it, right? So, but 700 extra bytes, maybe I could have fit that one and maybe even 2 more items into the game, which would have been very, very nice, right? Okay, so that's everything I wanted to tell you about optimizing. MDL is, of course, mainly an optimizer. That's what I built it to be, but it can do many other things, right? I added additional features just because I needed them right while I was working on my games for MSX or Amstrad. So I added them to MDL, and maybe they can be useful for some of the people if you are working on z80 projects. Okay, so I'm going to show you some of them. So the first is how to translate assembler from a given dialect to some more basic form of assembler. My folder, console and text editor, and I'm going to show you how to do something that sometimes, it actually happened to me a few months ago. So imagine that you are working on a game and you say, you know what, I want to have compression on my game, right? Because my files are too big, so I want to compress them. So you go to the internet and you search for a compressor for z80. And let's say that you find, I don't know, APLib, for example, and you go here to this forum and someone says, oh, here's a decompressor. It's like, oh, you think, great, so I'm going to use it. So I don't know, you copy the code, right? So I copy and I paste it here on my editor. I'm going to save it as, I don't know, where am I? Desktop. I'm going to save it as aplib.asm. And I say, great. So I'm going to compile it for my project. So let's say that you use Glass, right, as your compiler. So you say Java jar glass, and you say aplib, and say I'm going to compile it to aplib.bin, right? And you run it, and whoops, it doesn't work. So you go back to the code and look at it. It's like, oh, wait a minute. Right, because this is not Glass syntax. This is sjasm plus syntax. You see, we have those columns again that we just saw a minute ago. And we also have relative labels and things like that. It's like, oh, wow. Okay. So at this point, this is what happened to me. So I had to translate this file by hand to use it. But MDL can help you. So you can say, for example, Java jar Mdl aplib. Now remember that this is sjasm syntax, so you say dialect sjasm plus, and you say, and I want to just save it. I don't want to run any optimizer, right? I just want to load and save, and I'm going to save it as aplib. Oops, aplib mdl asm, right? And that's it. So now MDL has generated this other file. And I'm going to separate it so we can see them side by side. And what it has done is, you see, this is in the left is the original file, and on the right is the file generated by MDL. So there was this macro at the beginning that MDL has removed, and it has actually expanded. So for example, in the original code, depending on whether this constant was defined or not, it would define the get bit macro as something or another. In this case, it's defined as get one bit, right? So you will see that in the code generated by MDL, every time that there's here get bit, we get call get one bit, which is the expansion of the macro, right? And also these columns have disappeared. And now after this call, we have the JRNC to K0, right? So it is now in some standard z80 syntax. The other thing that this code had is there was these relative labels, right? This dot at 0, which basically these are relative to this absolute label. So MDL has the derelativized, however that is pronounced, has made them not relative. So now instead of dot at 0, there are no LWM dot at 0, right? So now they are absolute labels, which are more compatible with other assemblers. And finally, one thing that you would see is, you see here this exa instruction, and if you know z80 assembler, you would say, wait a minute, that is not an instruction. This is not a z80 instruction. But this is a shorthand in sjasm plus for xaf, af quote, right? So MDL has also translated that to the standard assembler notation. And now, hopefully, if I now try to compile this with Glass, Yep, so now I was able to compile it. So if you ever have this problem that you want to use some source code from someone else that uses a different assembler, maybe MDL can help you to translate that code to some default syntax that then you can just import into your project and use. Okay, so what else can MDL do? Code base, and I have here again my folder, my terminal, and my text file. So I'm going to use this code base to show you a few other features of MDL. So what I've done is I have already run a collection of commands from with MDL to generate a collection of files that MDL can generate and can be useful sometimes. For example, the first is, of course, the typical symbol table that all assemblers generate, right, where you have labels and the addresses corresponding to these labels, right? MDL can also generate this different type of symbol table, which includes both all the labels, but also all the constants that might not be labels. And this has been very useful to me for debugging, because sometimes, so we define constants by expressions, which MDL prints here in a comment, right? So it generates the constant, the final value it took, and then the expression that you actually used in the code to define it. And sometimes, like I thought some expression was evaluating to some value, but it's useful to see what is the actual final value that it's being evaluated to. And that has helped me find more than one bug. So this type of symbol table might be useful. The other thing that it generates, let's go in order, is this stats file that I don't know why they call it stats.asm. It should be a text file or a TSV file. But basically, this is just a list of all the files in your program saying how many bytes do they use, and then how many bytes in total if you pull from the include and inc bin statements, right? So if we look at the main file of Spelunker uses 1002 bytes, but if you include all the includes, it's exactly 32 kilobytes, which is what the game actually uses, right? The next one is this out dot dot, which is a graphical visualization of this, right? This is just a dot file. You might be familiar with dot files. They are basically, graph files, and I have converted it to a PNG file here with the typical .unix tool. I think it's available also for Windows. And here you have the same information, but with boxes, right? So each one of these white boxes is one assembler file, and the arrows mean that this assembler file includes this other assembler file. And the white boxes are assembler files, and the gray boxes are binary files, right? These are included with inc bin statements. So you can see at a glance where you are using space in your program. And finally, the last one, how do I call it? Out.asm, which is generated with this asm plus. Where is it? It's here. It's basically the same assembler source code that you give as input, but it adds these annotations. It adds 3 columns. In the first column, which address in memory is this being assembled to? Then the size of that instruction and how much time, how many t-states does this instruction take to execute? T-states or whatever is the time unit in the CPU configuration you selected in MDL. And I know there's a lot of tools for editors like Vim and VS Code that actually show you this information. But something that is very useful, has been very useful to me, is generating also this first column, the address in which this code is being assembled to, because sometimes some optimizations I can only apply if I assume that certain pieces of code are in certain ranges of addresses, right? So seeing where each line of code or even variable, right, is being assembled to, you can also see where in memory the different variables are being assembled to. That is actually very useful. Let me see, where is that? I think that is earlier on. Well, I kind of find it now, but oh, here, right? So now you see where each one of your variables, right? These are the variables in memory. Where are they in the memory of the z80, right? So this has actually been also very useful to me for debugging, especially for debugging. And I just want to show you one more thing in the Spelunker code base. And the last thing I want to show you is how to generate binaries. So in previous versions of MDL, you could use optimized code. But in this last version, you can also assemble and generate binaries, right? I decided to add this feature because given all the machinery that I had already internally in MDL, it was actually very easy to just add a few lines of code to generate binary files. So this was not a lot of extra work at all. All right, so I have already here the commands. So I'm going to just compile Spelunker. So if I want to generate a binary, so the same as before, java-jar, the mdl.jar, and then I just give the main assembler file, and I just say -bin, and the name of the binary file I want to generate. Right? So this will generate a ROM file that I can just launch, for example, in this case with OpenMSX. And because I'm recording the screen, full screen, this is probably going to go super slow because my computer is a few years old already. But yeah, you can see that there's a binary that works and you can play. It is super choppy because my computer is really struggling to play this at the same time as recording the video. But the other interesting thing is, imagine that you want to have the optimizations that MDL gives you, but you really do not want to have them in your code. Because sometimes optimized code is very ugly, right? Like sometimes you have to do some very weird things in the code to save a byte. So you do not want to have that in your source code because it will make it messy, right? So what you can do is maybe you can just not do any of the optimizations in your code that MDL suggests you to do, right? But whenever you generate the binary, just tell it to run the optimizers every time, right? So here I'm compiling, but before saving the binary file, I say run the reorganizer, then the pattern-based optimizer, optimize for size, and then generate a binary. Remember that MDL executes the processes in the order in which you specify them in the flags, right? So I do that, and it starts finding a lot of optimizations, right? So apparently Spelunker was not very optimized, and it actually managed to save 661 bytes. It applied 493 patterns, and it moved 60 blocks of code to optimize the code, right? And it generated this new binary file that has all the optimizations applied, right? So if I run it just to verify that after all the optimizations, the game still runs. So MDL, all the optimizations of MDL, in principle, they are safe. So the game should still work. As we can see, it still works. And of course, it goes very choppy because, as I was saying, my computer is not very fast, and I'm recording, so this goes very, very slow. But the game works. So again, I think this is interesting if you do not want to optimize your source code, but still count on the optimizations of MDL, right? So you can still coding without doing all of those suggestions that MDL suggests, because some of the optimizations are a bit, not nice, right? Like for example, here, it wants you to add this instruction, right, with some masks here that might make your code a bit messy, right? So if you do not want to change your code in this way, you can just ignore it, and every time you compile your file, you just run MDL, and that's it, right? So that's the last thing I wanted to show you. So let's go back to my slides. And finally, what's next for MDL? So there's a few things that I want to do in the next versions. The first is I would like to improve the existing two optimizers, the code reorganizer and the pattern-based optimizer. They work fairly well, but there's of course a lot of room for improvement. There's lots and lots of optimizations that could be done in the code that MDL still doesn't detect and doesn't do. So I'm constantly trying to add more patterns to the pattern-based optimizer. And there's also lots of code reorganizations that the code reorganizer right now doesn't do, but it could do. And right now it doesn't do them for safety. So I I have identified some basic case in which moving code is safe, and that is what I currently do. But I would like to identify a few more scenarios where I can ensure that moving a piece of code is still safe and it's not going to break the resulting program. And I would like to make MDL do those reorganizations as well. Then, of course, I would like to add a few more optimizers. So at least I have 3 in mind. The first is an outliner, which is a piece of an optimizer that basically identifies common sequences of assembler instructions in the code and tries to abstract them away in functions, right? So that will make the program slower, but it will make it smaller, right? So it can be quite useful if you want to optimize for size. The second is a register allocation optimizer. This can help a lot in optimizing speed. For example, it is very common to overuse registers IX and IY because they're actually very convenient, right? They have indirect memory addressing with offsets, so it's actually very useful for going through arrays and structures, but they're actually very, very slow, right? So every time you write code using IX or IY, not every time, but almost every time, there is a faster way to do it using HL, right? So it would be great if MDL can identify those and make those changes. And of course, there's general optimizations of minimizing moving values around in registers, etc. Right? There's lots of algorithms for doing that. And the final optimizer I would like to do, which I thought it would be the very first one I would implement in MDL, but I guess it will be the last, is a search-based optimizer. There is already a search-based optimizer existing. It's called the Super Optimizer. I forget who is the author, but I think it was built in 2008, something like that. And basically the idea is you specify the input and the output, right? So this is a program that takes this as input and the output has to satisfy these conditions. And the program searches for all possible sequences of assembly instructions, trying to find which is the shortest or fastest sequence of assembly instructions that achieves the goal, right? So this, of course, is very hard because the space of possible sequences of assembly instructions is very large. And I think the original Super Optimizer can only generate sequences of like 4 or 5 instructions. But I think we can do better, and I have a few ideas that with which I think, or I hope we can extend to maybe even sequences of 15, 20 instructions. But anyway, so we'll get there when we get there. I also want to add more dialects and more platforms to MDL. Right now I support a fair number of assemblers, but there's a few others that I do not support. And if you want to use MDL, but you use an assembler that is not currently supported, by all means, let me know. And if you can send me a pointer to the documentation of this assembler, and ideally examples. If I don't have an example assembler file with which to work, I cannot do anything, right? I cannot test it. And ideally, if it's an open source game or open source project that I can just pull from GitHub and try to compile with MDL, that's even better, right? Otherwise, there's no way I can work with it. And also add some platforms. So right now I support the basic Z80 that is used in the Spectrum, the Z80 configuration in the MSX that adds these additional wait states, and the Z80 configuration in Amstrad CPC, which uses a completely different timing. But I think there's a few other instantiations of the Z80 processor that I would like to support. And finally, better integration into people's toolchains. Right now, you can use MDL in 2 ways. As I showed you, use via the command line or integrate it into your text editor like Sublime or Visual Studio Code or Vim, right? But for example, something that I've been working on is some people have asked me if I can use, if they can use MDL for optimizing code generated by the SDCC C compiler. So I've been working on that, and I got it to work for one of the games that was submitted to the MSX Dev competition, I think last year. It's called Anchors Away. So the author shared with me his makefile and helped me a lot on how to integrate it into the makefile. And I've managed to make it work, right? So the whole compilation works, and MDL optimizes the assembler code, and then it's all linked. So it all works in that project. But of course, I've only tested into that project. So if anyone wants to use it and tries it, that would be really great and very useful for me if you let me know if it worked or not. I do not think it's going to work the first time around, but the more people that try it, then the more errors that we can fix, and of course the better and more robust MDL can get. So that would make me very happy. So anyway, that's everything I wanted to explain in this video. I hope it was useful to you. I would really like lots of people to use MDL because in that way there's lots of bugs being reported and found, and it becomes more robust, which is the ultimate goal. And I hope you enjoyed the video, so I'll see you in the next one. Thanks.